Hey guys, Alan here. Today, I'm gonna extend and continue the previous video, as it was a complete waste of time. Let's start. First, what is an electron? It is a quantum material charged with negative charge. And the speed of it, just in small number of 2.18 multiplied by 10 to the power of 6 meters per second, or simply 218,000 meters per second. And also reaching the speed of light when a heavy atom is present, like uranium. Now, what is current and voltage? They are brothers. Voltage is there, current will be there as well. Current is called I and voltage is V. To find out current, you need to divide voltage to rastance. But what is resistance? It is the property of a material that limits current to flow. Less resistance, more current. High resistance, ultimate power loss. So now we know resistance, voltage, current. Let's find out current present in 5 volts. Resistance is called R for short. Let's go. First, voltage equals 5 but resistance of an 2 centimeters wire. Resistance is in ohms, and using the R formula, we get 0.000428 ohms. Now, 5 divided by 0.000428 is 11,682.243 amps array, but, physically, your wires will break down and melt the hell out of your wires and your power supply. So, this failed. Mathematically, it will provide 200 to 400 milliamps due to inner resistance of power source. Let's try 9V and in bigger width and height. 0.7 millimeters, 10 centimeters, jumper wire. Let's see the resistance. According to the same formula, we get 0.07 ohms or 0.1 ohm. Very low. Now say that the 9V is coming from an battery. Its resistance would probably be like 2/3 amps. So ideally, around 2 or 3 amps in shorted. 4 amps. Physically, resistance in the battery will almost limit to an safe value of 200 milliamps to 400 milliamps. Hey, you are wondering what is our formula? It's the Ohm's law. It states that resistance is I divided by V or ratio of IV and the resistivity formula. It states that R is P multiplied length and area getting divided. P is resistivity, which is ohm multiplied by M, moving on. Resistor. Resistor is a component used to limit the current going through, it also divides the voltage if 2 of them are in series. And resistor is very useful. Powering LEDs? You'll need a resistor or say goodbye to your LED. Using transistors. You'll need one to pull down. Every resistor has a color code or a value. Moving on, meet this, capacitor. This guy. You'll meet him in almost every circuit that's commercial. These guys are angels and devils at the same time. Their angel form is oscillating, smoothing, storing. They can allow any 555 timer to run on astable mode, that is oscillating mode. They smooth out voltage. They store energy, which is voltage multiplied by current and time. Devil's side, overcharging explosion. Discharging to human or conductive stuff. New plan for me, no capacitors for overvoltaging. And also, AC can flow through it due to rapid charging, discharging. Now, AC and DC, AC is alternating current, while DC is direct current. As DC's name suggests, it runs on a straight line, while AC runs on curved line going to a peak of positive and negative. AC made by Nikola Tesla, while DC, Thomas Edison. DC is great for things like low voltage circuits, high voltage circuits as well. It's less shocking than AC. AC is a nightmare if you want yourselves not getting hurt from it, if you're an electrician. AC is mostly available from your power outlets. It runs on many phases and sometimes one phase. Next, we have diodes. These are really cool, they don't allow current to flow in reverse unless it's high. They are small but powerful. There are like 10 types, which I'll cover in some else video. Let's focus on main. An diode is a semiconductor that has positive and negative fused to it. The positive and negative have some impurities to make them plus and minus. The positive side takes electrons from negative, which is giving them. When this happens, there is a region called depletion region, which doesn't allow positive giving electrons to negative, so current is blocked. LEDs are also diodes as they stand for light emitting diodes. The diodes are used to rectify, like convert AC current to DC current. So, I think that's enough. In the next video, I'll take about inductors and more. And also include the 10 or more types of diodes. See ya!